All right, this is lesson 3, linear equations in X. Before we get started, make sure your name, date, and period are on this paper, as well as the due date, so we don't lose track of all that. All right, let's get started. So what we're basically going to do today is see if possible numbers for X are solutions. If it's a solution, or it makes the statement true, as some of these questions will ask, means is it a possible answer? All right, so a solution means is it a possible answer, or is it the answer? Okay, so we're going to do a lot of substituting where we swap out the X for that number. So here we go. Let's write down the problem. 6x plus 5 equals 5x plus 8 plus 2x. Now this time, we're going to kind of draw a line right down the center. I want to play it like two different equations and see if I get the same answer at the end. So I'm going to swap out this x and this x for -3. So we get 6 times -3 plus 5. And over here, I'm going to get 5 times -3 plus 8 plus 2 times -3. Now we combine our terms. 6 times -3 is -18. Bring down your plus 5. -18 plus 5 gives me a -13. Over here, I have 5 times -3 gives me -15. Bring down my 8 plus 8. And bring down 2 times -3 is -6. If I add this all up, -15 plus 8 minus 6 also gives me -13. So does -13 equal -13? Yes, which means -3 is a solution to this equation. All right, let's go to number 2. We want to see, can I use x equaling 12 for this equation? So we're going to say 16 minus 1/2 x equals 3/4 x plus 1. And again, I'm going to swap out my x's for 12, which gives me 16 minus 1/2 times 12 equals 3/4 times 12 plus 1. Now, as you remember, I've told you this a million times, fractions just mean to divide. So I'm going to put my work over here. We have 16. We can't do anything with that yet. Minus, but over here, 2 can go into 12 6 times, and 6 times 1 gives me 6. And here as well, 4 goes into 12 3 times, and 3 times 3 gives me 9, and we're going to say plus 1 there. All right, and again, we're going to split this like we did up here and see if we get the same answer each time. 16 take away 6 gives me 10. 9 plus 1 gives me 10. Are these equal to each other? Yes. So it is a solution. All right, let's go ahead and go to the next one. I'm going to bring this up. All right, 3. Chad solved the following equation, and he says that x equals 2 is a true solution. So let's check his work. So we're going to say 24x plus 4 plus 2x equals 3 times 10x minus 1. And again, I'm going to swap out these x's here for 2. So 24 times 2, there's nothing to do with that 4, so it just drops down, plus 2 times 2 equals 3 times the quantity of 10 times 2 minus 1. All right, so now let's just combine all this up. And again, we're going to split this right down the center here. 24 times 2 gives me 48. Bring down that plus 4. And we have 2 times 2 gives me 4. Over here, I have 3 times. Remember, you have to do order of operations. Always do what's inside the parentheses first. So 10 times 2 gives me 20 minus 1. So this will give me 3 times 19. Now let's come back over here. We have 48. If I combine those, we have 8. So 48 plus 8. And my final solution on this side is going to be 56. Over here, 3 times 19 gives me 57. Are these equal? No. So 2 is not a solution. Chad is incorrect. Okay, let's look at 4. Again, we have this equation. We want to see, is x equaling negative 1/3 a solution? Could it work? So we have x plus 6 equals 8 plus 7x. I'm going to swap out these x's again, right here and here, for negative 1/3. So I'm going to have negative 1/3 plus 6 equals, or actually we can just draw our line right down the center there, 8 plus 7 times negative 1/3. All right, so we're going to add these up. I'm going to put a 1 under this 6 just to make it look like a fraction. I need a common denominator, so obviously it's going to be 3. So I'm going to multiply both of these by 3, and I get negative 1/3 plus 18 thirds. And when I combine these, negative 1 plus 18 gives me 17, and the denominator stays the same. Over here, I have 8, and then I have 7 times negative 1 gives me negative 7 thirds. And again, I'm going to go ahead and put a 1 under this. Make myself a common denominator of 3. So I get 24 over 3 minus 7 over 3. And then 24 take away 7 gives me 17. And the denominator stays the same. So as you can see, I got both sides the same answer. So yes, negative 1/3 is a solution. All right, let's look at the next one. Angel transformed the following equation, and then he stated that 4 would be a correct answer. So I'm just going to focus on the main equation first and then see about what he wrote over here. But first, let's just use what we have. We have 6x plus 4 minus x equals 2 times the quantity x plus 1. And again, I'm going to swap out those x's for 4. So I'm going to say 6 times 4 plus 4 minus 4. That's all on one side. And over here I have 2 times 4 plus 1. All right. 6 times 4 gives me 24. 4 take away 4, those actually cancel. So my final answer on this side is 24. Over here, doing the parentheses first, 4 plus 1. This will be 2 times 5, and 2 times 5 is 10. Is 24 equal to 10? No. So I don't even need to check his other equation because no, it didn't even work with the first original equation. All right, number 6. Claire was able to verify that x equals 3 to her teacher's linear equation, but the equation got erased from the board. What might the equation have been? So basically, we're going to write ourselves our own equation, as long as x equaling 3 is a solution. So you can make up any equation on these when they ask this. So I'm just going to help you out on what that really looks like. So I want my x to equal 3 and to get the same answer at the end, where they both equal. So I made up this one. 6x minus 3 equals 2x plus 9. And again, you can keep this simple. You don't have to have a very long, extravagant equation. I'm going to swap out my x's here for 3. So I'm going to get 6 times 3 minus 3, and I'm going to split this. 2 times 3 plus 9. 6 times 3 is 18. Bring down that subtract 3. And 18 take away 3 gives me 15. Over here, 2 times 3 is 6. Bring down that plus 9. And 6 plus 9 is 15. So, does 15 equal 15? Yes. So, I made an equation where my solution is x equaling 3. So, here's a question for you. As we've done a couple examples so far, does every equation always have a solution? And could you come up with an equation that does not have a solution? So we actually had a couple of them. If you look back at your work, numbers 3 and number 5, both of them came out to no. They did not have a good solution. So that proves this part right here, that no, not every equation is going to have one. So we're going to say no. There are times where you will have no solution. All right. We're eventually not going to say yes or no. There will be times where it's just that is the answer. And then if you get a no solution, or you would have had a no, like we wrote on 3 and 5, you would actually say the words no solution. An example of that is a lot like numbers 3 and 5, where you had something like 23 equaling 50. Does 23 equal 50? No. So this is an example where you would write no solution. All right. So now we're going to move to our lesson 4. I'm going to pull that up here real quick while you guys grab yours. All right, so lesson 4, solving a linear equation. So very similar to what we were just doing. Just this time, we're going to have a lot more steps and a little bit more math. All right. But stick with me and we'll get through it. All right, solve this linear equation and state the property of the very first step that you choose. So just the first step. You don't need to name all of the steps that you're doing, just the first step. So we have this very lengthy equation here. It should look kind of familiar from yesterday. We actually came up with this in one of our equations. I want you to state the property. So the first thing we're going to do is the property of combining like terms. We're going to put all the terms that are similar together. So all the x's together and then all the whole numbers together. So you cannot put an x with a whole number. Those are two different terms, okay? Even if we had two different variables, say x and y, only the x's can go together, only the y's can go together. So keep that in mind. So I'm going to write this out. We have x plus 2 plus x plus 4 plus x plus 6. All of this is going to equal negative 28. So I'm going to combine my similarities. And I'm just going to color them up here. That's an x, that's an x, that's an x, and that's an x. So make that look a little bit more x-like. All right. How many x's do I have total? I have 4 x's. So I'm going to go ahead and call this 4x. And again, the property here is going to be called combining or combine like terms. You'll also see it referred to as combining like constants. Same thing. So that is my very first step. So I'm going to call that step 1. All right, the next things I'm going to combine are my numbers without variables. So that 2, this 4, and this 6. So 2 plus 4 plus 6 is going to give me plus 12. And then the negative 28 comes down. The reason we haven't done anything with the 28 is if you remember from the last lesson, we were kind of splitting these up, right? So this doesn't have any relevance to this side just yet. It's over here by itself. Now, if it had other numbers, I could combine that with the 28. But since it's standing by itself, it's going to remain by itself. Now, we're going to solve for x. So this equation as it is at this point says 4 times what plus 12 will give me a negative 28. So the first thing we want to do is get rid of this 12 because I want the x by itself. So I have to get this 4x by itself. And in order to do that, I need to move this 12. You always take the opposite. So what's the opposite of adding 12? Subtracting 12. And what you do to one side, you do to the other. So my 12s fall down here below. 12 take away 12 cancels because that becomes a 0. My 4x just falls straight down. And then since both of these are negative, I actually add them, but my negative will remain in the answer. So I have negative 12 and negative 28, which is going to give me negative 40. Now this is saying 4 times what gives me negative 40? X equals negative 10. And that's my final answer. Okay, but again, my very first step was combining those like terms. Let's look at number 2. So we're going to solve this linear equation and again state the very first property that we use. So let's go ahead and write the equation. 2 times the quantity 3x plus 2 equals 2x minus 1 plus x. So the very first property I'm going to use, I'm going to put in a different color here. I'm going to use distributive property. So before I can start combining, I have to distribute. I have to distribute this too. Whenever you have a number on the outside of the parentheses, it gets multiplied to everything on the inside. So it's going to be 2 times 3 and 2 times 2. And that's called distributive property. Whatever's on the outside goes to everything on the inside. And it only gets multiplied. So it's always multiplication. So 2 times 3 gives me a 6. Bring down the x. Plus 2 times 2 gives me a 4. And there was nothing to distribute over here. So this just comes down. All right, so that was my very first step. Now I can combine my like terms. So over here I have a 6x and I have a 4. So there's nothing I can do over here. Over here I have a 2x and I have a negative 1 and then I have a plus x. I can combine these two, excuse me, because they are the same. 2x plus x, basically it's 2 x's. And one more x gives me a total of 3x. And just bring down that minus 1. All right, dropping everything else down here. Okay, now I can combine my terms going across the equal sign. And remember, whenever you cross this equal sign, you always take the opposite. Now, I could move the 6x. I could move the 3x. It really doesn't matter. I personally always encourage you to keep your x positive. So if you have a positive 6x here, and you have to do the opposite in order to cross these equal signs, then I'm going to get a negative answer over here for x. I don't like that. So let's move the 3. So what's the opposite of positive 3x? It would be negative 3x. And what you do to one side, you do to the other. These 3x's here cancel. And the only thing left on this side is that negative 1. So just write it down here. Bring down your equal sign. And over here, 6x's take away 3x's gives me 3x. And then just bring down your plus 4. All right, now, again, I want to get this x over here by itself because right now it says 3 times what plus 4 gives me a negative 1. And in order to solve that, I need to move this 4. So what's the opposite of adding 4? subtracting 4. 4 take away 4 cancels, bringing down my 3x. And -1 and -4 means I'm going to add, but keep the negative in the answer, and that's going to give me a -5. All right. So x equals -5. I'm going to divide by 3, and x equals -5/3. All right, let's go to the next one. All right, number 3. We're going to solve this linear equation here. I have x minus 9 equals 3/5 x. State the first property that we're going to use. All right. So the first property we are going to use on this one is called subtraction property, and you can abbreviate that, of equality. And just like it says, subtraction. So let me show you what that means. I want to combine my x's, and since my x's are on opposite sides of the equal sign, that means I have to take the opposite. So what's the opposite of positive x? A negative x, and that's where that subtraction property comes in. So I'm going to subtract x from both sides. Those x's cancel, leaving me with a -9 on this side. And then I have 3/5 x. Now, as I told you, there's always a hidden 1 in front of that x. So that's basically minus 1x, and I'm just going to make it look like a fraction, 1/1. So now I need a common denominator of 5. So I'm going to multiply both of these by 5, and I get 3/5 x minus 5/5 x. So 3 take away 5 is going to give me a -2. Denominator stays the same. Bring down your x, bring down your equal sign, and that -9 comes all the way back down. All right, now we got to solve for what x could possibly be. So I have -9 equals -2/5 x. Okay, now you could divide and take its multiplicative inverse here, or you can just multiply out that denominator. So if you ever want to get rid of a fraction, you can always just multiply out the denominator, and that looks like this. Since my denominator is a 5, I'm going to times this by 5, but what you do to 1, you have to do to everything. So even if there was multiple terms here, everybody would be multiplied by 5. My 5s here cancel, and this over here gives me -45 equals -2x. And so this is saying 2 times what, or -2 times what, gives me 45. So when I go ahead and solve this, I'm going to divide by -2 to both sides. My -2's cancel. And I get 2 goes into 45. Well, it would be a decimal. But what I can do is negative and a negative become a positive. And since I can't reduce that, and if I divide it, it's going to come out to a decimal, then that's my answer. It's going to be +45, however, because my negatives here cancel out. A negative on the top, a negative on the bottom, it's gone. So this would be my answer here. If you can reduce this, go ahead. But in this case, you couldn't. All right, let's look at number 4. Solve the linear equation and state which property you're going to use first. So we have 29 minus 3x equals 5x plus 5. All right, the property I'm going to use is going to be called the addition property of equality. All right, the addition property of equality. And the reason I'm going to add is because I'm going to move this 3x again to pair it up with its other x over here. And what's the opposite of subtracting 3x? It would be adding 3x. So that's where that addition property comes in. And what you do to one side, you're going to do to the other. My 3x's cancel, leaving me with 29 here. 5 plus 3 gives me 8x, and bring down my 5. 8x plus 5 gives me 29. Well, first, in order to solve this, I need to get rid of the 5 because I want the x by itself. What's the opposite of adding 5? Subtracting 5. And remember, the reason we're taking the opposites, because we're moving past or over these equal bars. The 5's cancel. 29 take away 5 gives me 24 equals 8x. And so the final answer here is asking us 8 times what gives me 24? Well, we all know x equals 3 then. All right, at this point, I'm going to have you guys do number 5 on your own. Give it a try, and then you're going to want to make sure you get online and do your problem sets for lessons 3 and 4. All right, I will see you guys in class on Monday.